So in the previous video we are using the stiffness method to solve the frames and beams in case of rigid structure. Okay. So in this video we are going to discuss how to use the stiffness method to solve the pin jointed frames. In your first structure analysis, which is analysis of determinate structure, you have the lecturer would have discussed with you what is pin jointed structure and what is rigid structure. So we know that rigid structures are those which in which there can be a generation of movement. Okay, pin jointed structures are those structures which will distribute loads as forces itself. Like for example, if I take the truss is a pin jointed structure. All the forces that are acting on the truss will be distributed as axial force itself. There will be no bending of any element within that given truss. In case of frames, as we had discussed in all the previous classes, they are rigid in nature and which will go bending also. The elements of that frame may also bend. In case of pin jointed structure, the elements of the frame will not be bending, will not be subjected to any bending because the forces are acting in axial direction itself. Okay. Now what we do is that this stiffness method, as we know, can be used to solve the continuous beam. It can be used for solving the sway and non-sway frames which are all rigid in nature, and the same stiffness method can be also used to solve the pin jointed structure also. Okay. So what we will do is I quickly try to explain you what is the pin jointed structure, and then we will try to understand how do we find out the stiffness of any element in a pin jointed structure. Okay. So assume this is your pin jointed structure. What we see in this structure is that there is no bending of any element. These elements will not be subjected to any kind of movement. Okay. All the forces that are acting will be either in tensile forces or it may be compressive forces which are axial in nature. So what is axial condition means? The point of application of force is exactly concentric. Okay. If there is any element like this, the force will be applied like this, either in compressive force or it may be of tensile force, any of the one. Okay. So such kind of force distribution or such kind of forces that are generated in every member is what our pin jointed structure is. So whenever you want to analyze any pin jointed structure, which is truss basically, you use two methods. One is method of sections, the other one is method of joints. So in method of section, what you do is that you take the section at any point and you take the sum, you use the equilibrium equation and you solve the forces in those, you solve the forces in those members where you are taking the section. So what you do in method of joints, you take a joint which is having, two forces, and because we have two equilibrium equation at every joint. I hope you remember every pin joint will be having two equilibrium equations. What are those two equilibrium equations? Sigma fx is equals to 0, sigma fi is equals to 0. So using these two equilibrium equations, there is no another equilibrium equation. What is that another equilibrium equation? Summation of moment equal to 0. We do not have that equation over here. So there are only two equations. As I told you, in pin jointed structure it is subjected to only forces, it is not subjected to any kind of moments. So we use only these two equations and we solve one by one joint, and at the end we will be solving all the forces that is created in all the members. Okay. So similarly here also analyzing of a pin jointed structure means nothing but to find out what is the force that is exerted on individual member, how much force is created in individual member. Like for example, if this is a pin joint, if I apply a force in the downward direction, there will be a tension force in all these members. Is this correct? So that is what we need to determine. We need to find out what is the magnitude of force that is generated in all these members. Okay. So let us first try to understand what is stiffness of any member in a pin joint. So as I told you, in case of stiffness, when I wanted to describe the stiffness for rigid frames, I use that term called as 4EI by L. So 4EI by L is representing the moment that is generated if there is a unit rotation that is taking place. If there is a unit rotation, the moment that is generated over there is called as stiffness. So the stiffness value was 4EI divided by L. Okay. So similarly here also we need to describe what is that stiffness is. Earlier the stiffness was represented by unit rotation. Here the stiffness will be represented by unit translation. Okay, so let us try to understand that. So before that, what we need to do is to understand the earlier concepts, the basic concept that was discussed in strength of materials, okay, or mechanics of solids. So we know that Young's modulus is equals to stress by strain. So what is stress? Stress is force by area, and what is strain? Delta L by L. So this equation can be written like this: PL divided by A into delta L. So if I want to find out how much is delta L, so what I need to do is delta L is equals to PL by AE. Okay. If I am interested to find out how much is the force, I need to know what is the cross-sectional area of the member. I need to know what is the Young's modulus, that is the material property of the member. Then I need to know how much is the deformation that is taking place. The deformation may be of elongation or it may be reduction. Okay, there might be increase in the length or it may be decrease in the length. If I apply the compressive force, the member will get reduced. So we need to find out how much is that change in length, which is delta L. So if we apply the tensile forces, it will elongate, and we need to determine how much is the elongation that is taking place. So this delta L may be of both positive or negative. So based on A is the area of cross-section area of the member, E is the Young's modulus, which is material property. Delta L is representing the elongation or retardation of that length, divided by the length of the member will give you the force that is being subjected. Okay. Now, by understanding this background, we will try to develop our stiffness matrix. Okay. So first, what we will do is we will try to understand what is stiffness matrix. How do we develop the stiffness matrix? Then I will tell you how to find out the forces in individual members. Okay. So let us first try to look into this example. So this is an example which is arbitrary. Okay. Let us say that these are number of the elements. It will be 1, 2, 3 like this. So let us call this as nth element. There can be n elements which are connected at a joint. This is a joint which is connected by these number of members. Okay, n number of members. So I can take any one of the member. Like for example, I will take this member. I will call this as ith member. Okay. Now this entire structure is these all members are connected at this joint. So this joint can undergo two translation. One is horizontal translation, the other one is vertical translation. So the degree of freedom in case of pin jointed is equivalent to the number of joints multiplied by the 2. What is 2? 2 is the translation that can take place. As I know that we cannot apply the moment here. There cannot be rotation in case of pin jointed structure. We should remember it. So there are 2 degrees of freedom. So if you want to find out what is the degree of freedom for any given pin jointed frame, what we do is we multiply with the number of joints with the 2. Okay, right. So anyhow, now look at this structure. This structure is connected. In this structure, all the members are connected at this joint, and this joint is having 2 degrees of freedom. One is horizontal, the other one is vertical translation. Okay. Now let us represent what is the coordinate system. X. This is my horizontal coordinate, and this is my vertical coordinate. So this side, if the force is applied on this side, it will be considered as positive. If the force is applied on this side, we will consider it as positive. Now if I get the force in this direction, it will be negative. If the force is in this direction, we will be considering it as negative. Okay, so you should remember it. So once this is done, what we do is that we try to find out what will be the stiffness of element. Okay, stiffness of element. Let us go here. If I want to tell you what is stiffness of element, so this is AEI into delta L divided by 1 is there. Okay, so we will try to understand what is this delta L over here. Okay, now in all these in this frame, we will take only one of the member. We will take one of the member, and according to the stiffness, what we do is that wherever the degree of freedom is there, we will apply the unit translation or unit rotation. In this case, it will be of unit translation. So this is my first coordinate, this is my second coordinate. There are 2 degrees of freedom. According to the 2 degrees of freedom, I have applied the 2 coordinate system. So first coordinate system will be in this direction. I have to apply the unit translation in the horizontal direction and find out what is the force that will be generated. Okay, let us do that. So first what we will do is we will try to identify the translation. Okay, let us take this member, ith member. Let me call the member as AB. So this member AB is subjected to horizontal translation of unit translation. Okay. So how much is this translation? So this member has been pulled in this direction. Because of pulling this member in this direction, the translation over here is 1 unit. It may be 1 mm, 1 centimeter or anything. Okay, you imagine it as 1 unit. So because of that, what happens is the member was having this original length. This original length will be reduced to this smaller length. Okay. So how much will be the reduction of this length? This was the original member. Because of application of unit translation, the member has reduced to A dash and B. This is dotted line. Okay. Now how much is the reduction in the length? The reduction in the length will be called as delta L from here to here. Now how do we solve this delta L? Delta L can be solved by knowing what is the angle over here. Let me call this as theta. So if this is theta, this is 1. So how much will be this one? If I take the cos of theta. So cos of theta will be equal to delta L. So this length will be called as delta L. Okay. Now if I have to calculate how much is the force that is exerted over here after the deformation, what is the force that is exerted here? It will be using this equation. So what is the equation that we got? Force P will be equal to AE into, what is delta L here? Delta L is cos of theta, right? So cos of theta divided by L, AB. Let me call the length of the member as AB. Now this is the force which is acting in the direction of the member. Okay. Now if I have to again resolve it in the direction of X, I have to calculate. Now I will call it as Px. It will be called as AE into cos square theta divided by LAB. Okay. Now similarly, if I have to find out how much is the force which is acting in the y direction, I have to calculate Py. Let me call it as AE into cos of theta sine of theta divided by LAB. Okay. So first what we will do, we calculate how much is the force that is exerted on the member after the deformation. Then we resolve those forces in the x and y direction. So in x direction it will be AE into cos square theta, and in case of cos square theta by L, and in case of y direction the force is AE into cos theta into sin theta divided by LAB. So this is the forces that are generated in first coordinate and in second coordinate. Now try to go back and understand what is stiffness. What is stiffness was telling you? You need to apply the unit deformation or unit translation in the first coordinate, and you need to determine how much is the force that is acting in the first coordinate. The force that is acting in the first coordinate in the member length, in the member AB, because of the unit translation, is A into cos square theta divided by LAB. Now similarly, what is your second coordinate? Second coordinate is in the y direction, right? So the force that is generated in the y direction due to the unit translation in the x direction is this much, A into cos theta into sin theta divided by LAB. Now what you need to understand here is, we have calculated how much is the force that is exerted because of unit translation in the first coordinate. Okay, in both first coordinate and the forces we have calculated in both first coordinate and the second coordinate. We have calculated this, but this is for one single member. This is correct. So we have calculated for only one single member. What we need to do here is, we need to calculate how much forces will be generated in individual members. I have calculated only for one member, which is called ith member. Similarly, we need to calculate for 1, 2 and till the N. If I take the summation of all those forces which are generated in all the member because of unit displacement in the first direction, in the first coordinate, that will be called as P11. Okay, that is what I have solved here. P11 dash is representing how much is the force, the same here. This is the same equation over here and here. So this is the force which is generated at the first member, the first this member, ith member. Okay, and this force is generated because of application of unit translation in the first coordinate. Now similarly, P-21 is representing the force which is generated in the y direction, which is in the second coordinate, because of unit translation in the first coordinate. Okay, so this is representing the forces that are generated in only one member. Now if I have to find out how much is the forces that are generated in all the member, what I should do is, I have to take the summation of all P-11 values. So it will give me like this: summation of AE into cos square theta divided by L is representing the K11. Okay, so I will call this as K stiffness matrix. I will call these forces as K values. What is K value? K is the stiffness of elements. Okay. Now the stiffness of all these elements will be called as summation of A into cos square theta divided by L. Okay. Now similarly, K21, what is K21? K21 is representing the unit force being applied in the x direction, and we have calculated how much force that will be generated in all the member in the y direction. Okay, K21 is now. Similarly, we can also solve for y direction also. Okay, so K11, K21, K12, K22. So K12 equation is remaining same as that of K21. We'll go and understand what is K22. Okay, to understand the K22, what we need to do here is we need to apply unit translation in the y direction. Okay, earlier what we did, we applied the unit translation in the x direction. Now we will apply the unit translation in the y direction. Because of that, there will be elongation. So this small increase in the elongation will be called as sine of theta. So from this, if I have to calculate how much is the force will be like this: P is equals to AE into sine of theta divided by L. Okay. Now we calculate how much is the force that is acting in this member, but we need to resolve it in x direction and we need to resolve it in y direction. So after resolution, it will be Px will be equal to AE into sine of theta into cos of theta divided by L. In y direction, it will be AE into sine square theta divided by L. Now we'll try to understand what is K22. K22 is nothing but Py. What is Py is representing? The unit translation is taking place in the second direction, and the force we are calculating is also in the direction of second itself. So that's why this is what our equation will become. So equation is summation of A into sine square theta divided by L, which is nothing but the summation of all the forces that are generated in all the members, okay, due to unit translation in the second coordinate. Okay, so this is your K22, K2. So you need to remember all these equations. So this equation will help you solve the stiffness matrix for a given pin jointed frame. Okay. So after solving what is the stiffness matrix, next thing is to find out the displacement. So what are the two displacements we are calculating? We are calculating how much is the displacement in the first coordinate and the second coordinate. So we will have the translation in the x direction and translation in the y direction. And how do we find out that? It will be found out from inverse of stiffness matrix, which we have developed using these equations, and inverse of that stiffness matrix multiplied by the force matrix. Whatever the force that will be applied in these two coordinates will be considered, and from that you will calculate how much is the displacement. So there are two displacements which you can find out at this joint. So let me call the displacement at this joint, let me call it as joint A. So at joint A will be dAx. What is dAx is representing? This is the displacement that is taking place in the x direction. Now similarly, dAy will be also there, which is the displacement that is taking in the y direction. Okay. Now these are the two displacements which we have calculated. Okay. So once we calculate how much is the displacement at the given joint, right now in this frame we have only one joint. We may have n number of joints. Based on the number of joints, number of displacements will get generated. Okay. Here we have only one joint which is connecting all the members, so that's why there are only two displacements. Okay. Right. So I'm just hypothetically taking a member and I'm trying to tell you how much will be the net change in length of the member because of the displacement. So after calculating the displacement, what we calculate is we will calculate how much is the net displacement that has taken place in any given member. Okay. So this is member AB. This is the original member AB after it is subjected to some force and the displacement after taking place the displacement. This is my change length. So this is change length is A dash and B dash. Okay. Now here there is a translation that is taking place at joint A and also joint B. There can be a condition where both the ends can be getting changed in their length. Okay. So the change that is taking place at joint A, I am calling it as dAx, which is in x direction. The displacement that is taking place in the y direction is called as day. Similarly, there can be a displacement in at joint B, which can be called as dBx. dBx is representing displacement that is taking place at joint B in the x direction, and dBy, which is representing the displacement that is taking in the y direction at joint B. Okay. So once we solve this, what we need to do is to find out how much is the net change in length of the member. So to calculate the net change in length of the member, what I do is dBx, whatever the displacement that has taken place in the joint B, in the x direction minus of the displacement that is taking place in the joint A in the x direction. So dbx minus dax multiplied by cos of theta b will give you this change in length. Similarly, dby minus day will also give you the multiplied by sin theta ab will give you how much is the change in length that is taking place. Okay, so the net change in length of the member will be given by this. So this is can be also called it as delta L. Okay, so this is your net delta L or net change in the length that is undergoing this member. Okay, now to calculate the force in this member, what we need to do, again we have to go back to this equation where if you want to find out the force is equals to AE into delta L divided by L, right? So we already know that we are calculating the force in the member PA. So AE divided by LAB into this delta L. Okay, this delta L is representing the net changing length of the member. So we'll substitute here and we'll find out how much is the force. So this is a generalized equation which is used for a member AB. Now similarly we can calculate the forces in all the members by using this equation. The only thing that you need to keep on changing is the length here. Okay, and also the value of theta. Theta value will change from one member to the other member. So dbx and dax, dby and dy will remain same for the members based on the condition. Okay, we need to refer the condition. On that basis we need to use this equation. Okay, when we are solving the problem I'll explain you again how to use these equations. Okay, so what you do is that you watch this video again, try to understand what are the equations that are generated. So these are the equations which are giving you the stiffness matrix, and this is the equation which is giving you the forces that are generated in the members. Okay, so we already knew this equation. What is this equation? This equation is to calculate the displacement is equals to inverse of stiffness matrix multiplied by force matrix. So remember all these equations, write down this derivation. In the next class what we'll do is we'll solve a problem on pin jointed frames. Okay, thank you.